morning, everyone. My name is Jaime Ribote IV, the leader of Team Hisoka, and today we are going to talk about relations and functions and how we can relate relations and functions to real-life situations. But before we head on to our discussion, let us first introduce ourselves. Good morning, everyone. My name is Jaime Ribote IV, the leader of Team Hisoka. First, before we start our discussion, I would like to give a brief introduction regarding relations and functions. Relations is a relationship between an output and an input, whereas functions are a special type of relation which derive from an output to a specific given input. That is just a brief introduction regarding relations and functions. What I just gave was a brief context regarding relations and functions. And now, to discuss relations even more, I would like to call on one of my group members, Rian Dasmariñas. Rian, you may now speak.
Thank you, Jaime, for giving a brief introductions about relations and functions. And now I will discuss about relations. A relation between two sets is a collection of ordered pairs containing one object from each set. If the object X is from the first set and the object Y is from the second set, then the objects are said to be related. Relations can also be defined as the relationship between two different sets of information. If two sets are considered, the relation between them will be established if there is a connection between the elements of two or more non-empty sets. These are some of the definitions of relations when it comes to mathematics. And now to give additional information regarding relations, I would like to call on Christine Estrada.
Thank you, Rian Dasmariñas, for giving us the definition and concept behind relations. And now I would just like to give additional information regarding relations. Relations is also a subset of Cartesian product, or simply a bunch of points or ordered pairs. In other words, the relation between the two sets is defined as the collection of the ordered pair, in which the ordered pair is formed by the object from each set. Relations also have different types, but we will just go over them briefly since it is a topic that will be further discussed by our next member, Rukna Piring. The different types of relations are the following: empty relations, universal relations, identity relations, inverse relations, reflexive relations, symmetric relations, and transitive relations. Now these are the additional information that I would like to give regarding relations. And now to give us examples of relations, I would like to call Shaira Langusta.
Thank you, Rian Dasmariñas, for giving us additional information regarding relations. As Rian stated, the different types of relations are the following: empty relations, universal relations, identity relations, inverse relations, reflexive relations, symmetric relations, and transitive relations. I would like to give further explanation regarding these different types of relations. First, empty relation. Empty relation is when no element of set X is related or mapped in any element of set X. Then relation R in A is an empty relation and also called as void relation. Next, we have universal relation. R is a relation in a set. Let's say A is a universal relation because in this full relation, every element of A is related to every element of A. It's a full relation as every element of set A is in set B. And to explain the other types of relations, I would like to call Luz Marie Fial Sanlao. Thank you.
Thank you, Shaira, for discussing the first two types of relation, and now I would like to discuss the rest of the types of relation. Next we have is the identity relation. If every element of set A is related to itself only, it is called identity relation, equals AA element above. For example, when we throw a dice, the total of if every element of set A is related to itself only, it is called identity relation. I equals AA element above. Next, we have the inverse relation. If R is a relation from set A, either SEBIER element of AXB. The relation R1BA AB element of R. For example, if you throw two dice, if R equals 1, 2, 2, 3, R1 equals 2, 1, 3, 2. Here the domain is the range R1 and vice versa. And after the inverse relation, we have the reflexive relation. A relation is a reflexive relation if every element of set A maps to itself, i.e. for every element of A, AA element of R. And next we have the symmetric relation. A symmetric relation is a relation R on a set A. If AB is element of R, then BA is element of R for all A and B element A. Then next we have the transitive relation. A symmetric relation is a relation R on a set A. If AB is element of R, then BA is element of R for all A and B element of A. And lastly, we have the equivalence relation. If a relation is reflexive, symmetric, and transitive, then the relation is called an equivalence relation. Woo! That was a mouthful. And next, to give us different example of relation, I would like to call on Luke Napiri.
Thank you, Liz, for giving us the rest of the types of relations. And now, I would like to give us some examples of relations. Give an example of an equivalence relation. If you note down all the outcomes of throwing two dice, it will include reflexive, symmetry, and transitive relations. Then, throwing two dice is an example of an equivalence relation. All functions are relations, but not all relations are functions justified. Let's suppose we have two relations given in below table. These are some of the examples of relations that I can give. And now, I would like to call on Gerald Garde to discuss to us what functions are.
Thank you, Luke, for discussing to us the different examples of relationship. And now I will discuss the question that most probably everybody has right now. What is function? Now, Jaime already discussed function briefly and give us introduction, but I will just further explain what he said regarding function. A function is a relationship which describes that there should be only one output for each input, or we can say that special kind of relationship, a set of ordered pairs which follows our rule. Everybody x value should be associated with only one value is called a function. This is what a function, but we can also define function in different ways. For example, a function is also binary relation between to the set that associate every element of the first set to exactly one element of the second set. Typical examples of function for integers to integers, or from the real numbers to real numbers. For example, the position of a planet was a function time. Now, but of this correct definition of function, they were just interpreted by different words, but in the end they are why the same concept. And now to give us additional information regarding function, I should like to call Nelton.
Gerald, for giving us the gist of what functions are. And now I would just like to give some minor information that we said by Gerald regarding functions. Before we move on further, let us remember that all functions are relation, but not relations are functions. Now we can discuss functions if we do not know anything about domain and range. Domain is a collection of the first values in the ordered pairs, while range is collector of the second values in the ordered pairs. And lastly, before Chrisella discusses the different types of functions and give some examples of functions, I would just like to enumerate the different types of functions. The different types of functions are the following: one-to-one function or injective function, many-to-one function, unto function or surjective function, and lastly, one-on-one correspondence or bijective functions. There are the other facts or definition that you need to know when you are dealing with functions. And now to discuss the different types of function and examples of function, I would like to call Chrisella Asuncion.
For giving us an additional information regarding function, and now I would like to further discuss them since they already enumerated the different types of function. First, we have one-to-one or injective function. It said that the function f p is to q is said to be one-to-one for each element of p. There is distinct element of q. Next, we have many-to-one function. It is a function which maps two or more elements of P to the same element of set Q. And after that, we have onto function or surjective function. It is a function for which every element of set Q, there is pre-image of set P. And lastly, we have one-to-one correspondence or bijective function. Function F matches with each element of P with a discrete element of Q. Every element of Q has a pre-image in P. And I would like to add some special function in algebra, but we will not discuss it right now. The special function when it comes to algebra are the following: constant function, identity function, linear function, absolute value function, inverse function. And now to give us some example of function, I would like to call Christine Angeli Estrada.
Thank you, Chrisella, for discussing to us the types of functions. And now, Jaime Bote will just give some examples of functions.
Now, we all might think that relating relations and functions to real life is impossible to do. But what we do not notice is that relations and functions have always been present in our day-to-day lives. We just do not notice it since relations and functions are concepts that are always present in our day-to-day lives. So, I will relate relations and functions to real life by giving you these 5 examples of relations and functions in real life. First example. If you look at a collection of people, you will notice that there is a relation between age and height. Generally speaking, if people get older, they get taller. Then they stop growing for a while. Then, at the latter point of their life, they start getting a little bit shorter. At any given point of a person's life, that person will only have one height, since a person can't be 5'9" and 6'5" at the same time. In a semester in college, there is a relation between a student and their final grade. A student can have different grades in different courses. In a particular class, there is a function between a student and their grades. Third example. Generally speaking, there is a relation between time and temperature, as in the weather. If you look at a particular location, there is a function between time. At any moment, the thermometer in that location can only read one temperature. Fourth example. Once you pull up to a pump to choose your fuel, the amount of gas needed to fill your car is the function between the amount of gas that is needed to fill your car. Of taking a particular taxi is usually the function of how long the ride is. And lastly, I have these examples of relations. The relation between a father and a son. The relation between a brother and a brother. The relation between a brother and a sister. The relation between a mother and a daughter. And a relation between the strength of a whole classroom to the strength of a whole school. Now that we're finished in giving a description, definition, and examples of relations and functions, and now that we are also finished in relating relations and functions to real life, all I can say now is that I hope that each and every one of you now understands the true meaning and definition of relations and functions. And I also hope that you can now identify real-life situations regarding relations and functions. So once again, we're Team Hisoka, and thank you for listening.